Let's talk about observer pattern. Observer pattern is a low level design pattern, but the concepts which we use, they can be used in the high level designs also. So watch this video till the end. In the end, I have discussed about the code which will give more clarity on how to implement this pattern. So suppose there is a particular system which is always updating. Let's consider this maybe a weather system. Now the temperature keeps on changing, the weather keeps on changing, there might be rain. Now there are a few apps which want to know about this weather conditions. So there is some weather system like which tells that there is rain going on or the temperature is too high, it's hot outside. In these times, the food delivery guys, for example Zomato, they want to send out a notification that it is raining outside, so the delivery partner might be late, or it is too hot outside, so please offer water to the delivery partner who is delivering food to you. These kind of notifications you must have seen. Assuming that internally they might have some weather system which is kind of updating the weather on the go. Now there may be various classes which might be sending various notifications. So from the top of our mind we can see two types of classes. The one which will actually create the notification and say that send this notification to different types of people. Another class would be which affects the prices. So for example, the delivery charges will increase. For now, let's suppose we just have these two different classes. One is for pricing, one is for notification. Now how will these classes know, or how will these systems basically know that the weather is updating or it has updated? So now as you can see that the line between the low level design and high level design is very much thin here. So for example, if you consider that the pricing is another microservice, notification is another microservice, and this weather system which is there, it is another microservice. Now how do these interact with each other? That comes as a part of a high level design. But for now we are just assuming that these are just classes. Pricing is a class, notification is a class, weather is just a class, and these classes want to know basically in a single threaded or in a multi-threaded system, they want to know that this weather class has any updates or not. It wants to know about various weather conditions which are there. So let's see what kind of functions would be there in each kind of these classes, or let's say interfaces. So the pricing and the notification class wants to know about the status of the weather. So we can call these as observers. The weather class which is being observed by these two classes, this can be called as observable. So we will first understand the design pattern with the help of these observable and observers interfaces, and we'll see that how these interact with each other. Let's first understand that how will these classes get to know about the weather system. Now what are the ways you can think of? I would suggest you to pause the video at this point and think of what are the two different kinds of ways in which you can notify these two classes that the status has changed. There is some change in the weather status. You want to notify these two classes. So as you might have thought of, there are two types of ways. First is a push way. So whenever a change happens, it will push it to the pricing also, it will push to the notification also. And the other way is that these two classes keep on polling all the time. So we can say that after every 10 seconds there is some kind of job running in these two classes which will then call the weather to ask that has the weather changed, it will keep on asking. Or the other way could be like whenever there is some significant change, this class would definitely notify the pricing class and the notify class. Now which method do you think is the best? Now this is a question which can be asked for a high level design also. Like what kind of way is the best? Is the push way better or the poll way better? So most of the times for the high level designs you will kind of get an answer that a hybrid way is better. So for example, suppose there is Instagram. Whenever a user puts something, it has to be sent it to its connections or friends. So what would be the best possible way? One possible way that all the connection which are there, they are consistently polling to the people they are connected to all the time. Another way would be that whenever someone posts something, it is sent to all of its friends. Now this posting to all of its friends is probably a better way because the number of connections would be very large if we are kind of polling from everyone, and it is a quite wastage of resources. So whenever a normal person like me or you post something, it usually just sends a push notification to all our friends or something like that. But what if a celebrity posts? Now whenever a celebrity posts something, then it is not possible to send to millions of followers these notifications. So at that time, a poll based mechanism is kind of better. So whenever someone actually comes to the platform and then starts polling, then it is actually showing it to the user that this guy had posted before. Now this kind of question can be asked for this low level design also. So is this a push or a poll? What method should we follow? Should we follow a push method or a polling method? Now considering the wastage of resources which will be happening with the pull method, we'll go with the push method. And that's what observer pattern is about. It is a kind of push mechanism by which you tell the different observers that the state of the observable has somehow changed. And how do we do that? That's what observer pattern tells us, that how do we implement this kind of scheme that the observable is telling to its observers that I have changed. That's what we are learning today. So to implement this observer pattern, let's suppose we have two interfaces. One is the IObservable interface and one is the IObserver interface. Now in these interfaces, what will be the functions? Now one function would be an add function in this IObservable to basically add any of the IObserver who want to know about the status of this observable. So first pricing comes a new that I want to know the status of the weather, we add it to it. Then some notification comes, a notification class comes, then we create add it to it. Then another class someday comes up that I also want weather updates to do something, whatever it wants to do, then we add it. Similarly for removing, we just remove the class which we do not want to now listen to the weather updates. And then finally it has the notify. What will this notify do? This notify would basically inform all the observers that there has been some change in the weather. Now as you can see that we have to notify all the observers whenever this notify is called. So therefore we must maintain some kind of list of all the observers who have kind of subscribed to listen to whatever is happening. So we must have a list of observers. So we have this list. So this is the basic design, basic low level class design which we will follow, and this is a weather app, weather class which we have. Now one important point to notice about it is that this weather class, which is a type of IObservable, will also have function which is kind of necessary for these. That function will be called getState. Now why do we need this getState function? So when we are notifying it to the pricing and notifications, we are not telling the actual state. Now these two classes would need some kind of information that what is the current state of the weather system. So one way would be that in this notify itself, we kind of send the state also directly to the IObserver, or the second way could be that these classes would then further call this getState function of the weather class to know that what's the state of this particular system that we are kind of observing. To be able to call this getState function, these classes should also know or should also have the access to one of the instances of this weather class. So we would have kind of weather w in this also, and basically we would simply call w.getState. So we will call this w.getState probably inside this update function. Whenever this update function is called, we'll call a getState. One important thing to notice here is that we are here taking an instance of a weather class directly. We are not creating an instance of using this interface IObservable. Why is that? It is simply because this class knows what it is observing. It does not need to have a generic interface to it. But whereas here we are using an interface, because this observable don't need to know that who is observing me. It just need to call the update method to it. So therefore here we are using an interface, but here we are using the actual class to call a particular function of that object. So that's the basic low level design of observer pattern. Now we will be discussing code after this. Before going to the code, recently a tweet went viral saying that Uber charges, or there are different apps which kind of monitor the battery, and whenever the battery is low or high, according to that they give the prices. So for example, if your battery is really low, it will give you high prices for the ride, whereas if your battery is high, it will give you normal prices. In this kind of system also, we kind of would be having, if this is true, I'm not sure if this is true. If this is true, we would be having this observer pattern being implemented. So whenever a new app comes in, it must be subscribing to the battery app, or like whatever is maintaining the battery. So we would see the code example now using this weather example that we discussed, and we will also see the code for the battery example, like if you want to update the prices on the basis of what is the total battery which is remaining in the mobile phone. So let's just jump into the code. We have an IObservable interface like we had. So in this we will have a list of observers. We will have three methods: add an observer, remove an observer, and notify. Similarly, we have an IObserver interface. In the IObserver interface, we just have one method called the update. Now this battery phone is kind of, you can consider your battery app, which is a kind of observable. It has some battery level which we have defined as one of the member variables. It will now implement observable in that the add method. So it will simply observers.add that particular observer. In the remove method, it will simply remove that object of observer. In the notify, it will notify all the observers which are there to do app.update. So that's the reason of having observer update method in the IObserver interface. And finally, this is another function which we have defined for this particular class to get the state, to know basically what is the state of this battery. Now for the observer, we just have this, suppose Uber class. There can be other classes also, different apps which want to know how much battery is there. So now what it will do, it will also implement the IObserver interface. In that, now as you see, we have taken an instance of battery phone. So, like I discussed on the whiteboard, that we will have the class object itself, not the interface, in this observer class that we implement. So in this, as you can see, we have battery phone. We initialize it, and in the update method, what we are doing, we are simply just trying to get the state and doing, like, if the battery is less than 10, then do get price into 10. Like, this is just a simple logic that we have kind of written. So this can be one of the way in which they might be controlling your prices on the basis of your battery. I'm not sure that if it is true, but maybe. Now coming to the weather example that we discussed in the video, similarly we would have the interface. The interfaces will remain the same. As you can see, it is exactly the same interface we used for the observable. Sorry, this would be observable. We have used the exactly same interface. Similarly for the observer, we also have the exactly same interface with just one method. Now in this, our observable is the weather, so we will create a weather which implements the observable. It has a status just to maintain what's the weather status as of now. Similarly, in the add and remove, we'll do the same things. In the notify also, we'll do the same things. We'll just do observer.update. Now we have implemented a new method for this weather class called the getState, which will give the return this status object. We can assume that this is a status object containing the weather conditions. Now for the observer classes, we have two classes. One, the pricing class. So this is a pricing class which is implementing the observer interface. This will have the access to the weather class as we discussed. So you can see that there is an access to the weather class. Now this weather class will now be used to get the state. So whenever the update is called, whether we do weather.getState to actually get the state of the weather at that time and do anything with that status, whatever we want to do with that status. Similarly, if we go to the notification class, we are doing exactly the same thing in that also. The complete implementation is basically same. Whatever we are doing in this do something will be different for the notification class, and it is different for the pricing class. So this is what is the observer pattern. That's how you implement it as a low level design in Java. I took the Java example. You can implement it in other classes, other languages too. I've not done the basic imports etc. which are there, so this is just to give you an idea how the code would look like. So I hope you like this video. See you next.